Yes. So, hi, I'm Oliver Gao. I'm the director of Cornell Systems Engineering Program. I will be conducting this what I call systems conversations with our prestigious speakers that we bring to Cornell to deliver a systems seminar talk. So today I'm very delighted to have Dr. Luis Bojórquez-Tapia, and he is actually a researcher at the National Laboratory of Sustainable Science, or we call LANCIS, and also Institute of Ecology, National Autonomous University of Mexico. So his research addresses diverse aspects of transdisciplinary research within the context of sustainability science from the perspectives of simulation of coupled social, ecological, and I also assume social, ecological, as well as technical
Yes.
Systems. And that is related to decision theory as well as environmental conflict settlement. So I think this is really a nice match, as I was talking to Luis earlier, to what the Cornell System Engineering Program is pursuing. So Luis, it's very great to have you here. Just looking at your bio, I was so impressed with the diverse background, and also really I feel the very nice system, the vision you have about not only our research, also about our society. I think, including myself, our audience would be very curious to learn more about you, your research, and your career, whatever you would like to share with us.
Yeah, well, thank you very much for inviting me to Cornell. I'm very impressed to this first introduction. This is my first time here, and we are very welcoming weather right now, which is very nice because for me, coming from Mexico City, having this exposure to very cold weather is a very good experience.
Mm-hmm.
And what I would like to say just a little bit about what motivates me as a professional, as a researcher, because I started my career as a biologist.
Mm-hmm.
I was trained more like a taxonomist than any other thing.
Mm-hmm.
So I was very far away from the systems thinking that it's that we're talking now. And in those days, at least in Mexico, it was kind of new. And in my school, in the National Polytechnical Institute. But in reality, I didn't want to be a biologist. I had my training like that, but I wanted to be more like a natural resource manager.
Mm-hmm.
And that led me then to other things, to other ways of thinking, basically in watershed management. So I got a PhD in watershed management at the University of Arizona.
Mm-hmm.
And then I got a great exposure to something very important, that it was on conflicts and how do you solve conflicts for the use of natural resources.
Mm-hmm.
And that immediately connects you to something more that you immediately see in within a conflict. You have to start looking at things in what now call a systemic way, a set of connections and feedbacks that give rise to these conflicting situations.
Mm-hmm.
And then these notions of socio-ecological systems and sustainability, science and resilience got momentum to the point that we are now with a wonderful set of technologies, techniques and concepts ready to be used to solve conflicts.
Mm-hmm.
And I think that the technologies and concepts are going to evolve very rapidly in the very near future. And what we are now lacking a little bit, in my perception, is more a philosophical way of looking at conflict, looking at systems, and actually taking a deep look of the things we're doing as researchers in this field.
Mm-hmm.
So that motivated me to look more to philosophy rather to equations. I'm not very good at math to begin with, so and then also to see the moral, ethical issues that drives my research. And I started it basically trying to explain myself what I'm actually doing, how I'm actually intervening. And that opened on another body of very interesting literature, very complicated literature, and that ends up that how you can conduct a research in a way you put your skills or your knowledge to service society needs, to open up democratic ways of decision making, rather than being only a technocrat at the service of certain group or certain way of thinking. So it's a very difficult way because of working, because on the one hand we say that we have all these very challenging issues and concerns in current societies all over the world, with complex systems, with deeply uncertain processes, and we have all these very intricate concepts, technologies, tools, analytical tools, that we have to be sure that we actually not imposing to society, hiding these technologies and tools, certain ways of thinking. Mm-hmm. But actually what we need to do is to provide a means in a way that our analysis are not only integrative in the traditional way, mm-hmm. but are also transparent, and we as a researcher therefore accountable for what's our output. So what I see is we're in the fringe of this moment right now in the system thinking of making this connection, and I think that's going to be the critical step for the future of what we call systems thinking.
That's wonderful. Thank you, Luis, and thank you for sharing like the evolution, like of your or the progress of your career. And I think you said that you started as like a biologist, and then gradually as you were trying to better understand and address our societal challenges, and apparently I think your view or the field of your research has expanded. Mm-hmm. Of course, in biologist, to me, it's a scientist. And then I think one point you made is that as you were looking to these things, gradually you became more and more interested and immersed into philosophy. Mm-hmm. And I totally understand that feeling, because you can see that like trained, educated early on as like kind of biologist, scientist, or a kind of technocrat. Mm-hmm. Right, and then you move on, you realize actually, yes, technologies are important. Mm-hmm. However, technologies alone are not going to be the solution.
Yes.
To our societal needs. Let me ask you a very short question, Ethan. Through this process, of course, as you go from this kind of just one scientific discipline, which say biology, and to now with these kind of complicated systems challenges as well as philosophy you are trying to explore, are you becoming happier, or are you becoming more optimistic, or as you see more challenge, all this complexity, are you feeling less optimistic?
That's a very good question. I think it goes beyond optimism or happiness. It's very it's very philosophical. How do I know that happiness exists if I don't know what unhappiness is? If I'm unhappy, then I can contrast to something. Which it goes beyond to that statement, because it goes very deeply to one of my concerns as a researcher. Because what you're implicit in your question is, how do you generate a metric to know that you are happy?
Yeah.
So the way of getting that metric is very subjective. It's very inside of your way of thinking. It's part of your mental border, your values, your needs. So the thing is that I have to connect, as a whole human being, these intangible aspects of what happening is with the tangible aspects of the real world.
Yeah.
So that connection, it's important. I would say, since I've been in many times unhappy in my life, I can say that this transition in my career, I don't know if I've been successful or not, but it's been very satisfying in many deeper questions that I had, that of course that make me happy in some ways, but make me very unhappy in some other ways, because then you have to contrast and compare with establishment systems that of course creates your frustrations and your complexes, insecurities arise.
Thank you. Thank you, Luis. Thank you for being so humble. And you say, you are not even sure. You are not sure whether you are successful or not. And actually, I was reading, and people say actually more successful people, actually, because they have a bigger view that gives them opportunity to realize, how tiny a human being is, such as that actually they don't really think they are successful, even though they are really successful. So maybe I can probably kind of modify my earlier question a little bit, because when we were looking only in one discipline, and for example biology or some other kind of technology, we're deeper into that field, and then we probably have some excitement coming one after another. So maybe my question, however, when you open your mind up, when you see a bigger complexity in comparison to the individual single field we were in before. So my question probably was, should be kind of framed as, when we are in a single field, we could become easily excited, but in a small world, versus when you open your mind up, you could easily become concerned while you see the bigger world. So that's from my kind of, being easily excited in a small world versus being easily kind of concerned in the bigger world.
Yes, and that's interesting, because that's something that sustainability sciences, it's very important. I emphasize the plural in sciences, and because that's a very systemic way of thinking, and just talking about science instead of science is just to put a pluralism touch in that. Just be very open, because getting back on your question is that you need to be specific and very clear of what are you doing as a researcher, because you're intervening in a system in order to make it better. That's the whole point of sustainability. Sustainability is a moral concept. It's like justice. Society is not going to be perfectly just. It's not going to be perfectly sustainable. That's what those are ideals. But the closer we are to those ideals, the better society is as a whole. So the whole point is that it's a very difficult problem. It's with many different points of touch. So you need a a way of organizing that complexity to what we call systems. And going back, what makes me happy, provides me with happiness, is that intellectual exercise to getting that together, and at least trying to be as accountable as I can be, that I can contribute to moving society closer to that ideal.
Mm-hmm.
And that, I think that's an endeavor that many people would like to pursue. And systems thinking, it's a way of pursuing it in a very efficient way for people like me.
That's wonderful. Luis, we're talking about this, reminding me of a TED Talk that I recently viewed on YouTube, and the person was talking about happiness. Of course, I don't want to stay here on this happiness topic for long, but I just want to mention that he made a point saying that happiness coming from, they call happiness comes from flow. It's kind of a person being lost, being immersed in the flow of work or thinking, such that your mind is totally immersed in that flow that gives you the maximum happiness. And speaking of that, I think kind of your time, your mind spent in the flow of bringing our society closer to that sustainability ideal that gives you happiness.
Just trying.
Yes, that's right. That in the flow of right kind of spending or squandering our mind and the time in the thing that we believe it's good.
Yeah.
Right. So I think you've been doing this. Your career has been kind of devoted to this kind of, as you say, bringing our society closer to that sustainability ideal. So now, either both from a philosophic as well as from a empirical perspective, since you've been spending time in this sustainability, both sustainability science and also I assume sustainability practice, since you also work with government. So what do you view as the key, top level challenges or barriers for our society to get closer to that sustainability ideal? So what are the key system challenges do you see?
It's very easy to fall in the way of thinking that we have to change our way of living and our values. That's been said for many people and supported with very good arguments. So let's take that like a premise. We have to change those values. The question is, how do you achieve that? So one way of doing that is making the invisible aspects of what we call sustainability problems visible. That's one thing. That's very important, because then we can do things that we visualize the problem and the complexity of the problem. Then we can start doing something about changing our values. And society has done it several times in the evolution of society. That's why we have now human rights. I mean, when I thought that I'm very glad I live in this time and epoch, even that it's a crazy world, I know that, but at least we have painkillers, even over the counter. We have naproxen and all these aspirin, that's very good. We have antibiotics, and we have human rights. Even that these three things have many problems by themselves, but I wouldn't like to live in a world without those things, just to say a few things. But in the way we're evolving and solving these problems and complexity, we change our values. Now we expect someone like me, something that my grandparents didn't expect, like live free of pain, live free of very harsh infections. So then those are becoming like our rights. So our values are changing and through time. But now we live in a time that we need better tools to modify our way of thinking as a society and as the society values that drive the main problems that we face as human beings in the world. So I think that there's a place for systems to provide without visualization of the big problems and the potential solutions and the big dilemmas and paradoxes that we're going to face like a society.
Yeah, so that's kind of of course I don't want to pry into the talk you are going to be given later, but I think you mentioned we are facing a paradox.
Mm-hmm.
Can you do you want to talk a little bit more about the paradox?
Yeah, there's related. For one thing, we face these complex problems, and then if we accept that we're complex, we are more ignorant than we believe that, and then there's this tendency to try to solve this problem using simplistic tools, and that doesn't work.
Mm-hmm.
You're hiding reality with simplistic tools. On the other hand, you have these mathematical tools and modeling tools that are very complicated.
Mm-hmm.
That the problem is that what we call the mythological decision maker cannot understand. So and this comes also with the paradox. On the one hand, as sustainability scientists, we're compelled to provide solutions. And providing solutions is one way of doing things, but on the other hand, we have to look at the longer term societal issues, sustainability issues that's going to appear. That's another way of thinking. So what I see is that we have to decide at in every moment which part of what role we want to play at any moment in society, and that's a difficult challenge. You cannot do both at the same time. You either provide solutions right now, or look at the longer term. And for example, we all know that climate change is one of this example. It's the longer term, but what are the specific solutions for any given aspect? So I have this big gap that has been very difficult to fulfill. And we're talking about climate change, that there's a lot of efforts and interest. But look at some other problems like in society, like water systems in megalopolis like Mexico City.
Mm-hmm.
So that's another ballgame, because then you're playing with very direct impacts, but also what's going to happen with the megalopolis in the future. Can we imagine cities like with 50 million people? Are we going to be able to manage those kind of systems? And so on.
Yeah, that's wonderful. So maybe I think kind of to translate this kind of research philosophy that you have. Of course, I noticed you will be conducting many projects to help, like the Mexico government as well as I think the academics and practitioners
Mm-hmm.
to come up with solutions. So now if we put our feet on the ground, I know like kind of philosophic thinking. I really appreciate that. It's kind of even for my PhD student, I say we allocate a certain amount of time
Mm-hmm.
for this kind of philosophical thinking, so that we do not lose the big picture. But of course, after we have enough big picture thinking, and we need to put our feet on the ground,
Sure.
so that we can solve the real world problems. So, say thinking like in the coming 5 to 10 years, what would be some kind of top priority problems that you would aim to address, or your research group would like to tackle? What are the top priority problems?
Yeah, that's a very interesting one. So what we are addressing now is vulnerability in coastal areas in Mexico, and basically in two very different areas. Environments. One is the tip of the Baja California Peninsula, which is where Los Cabos is, mm-hmm. which could have urban sprawl that it's transforming the territory very rapidly. Very successful tourist resort. And then we have the peninsula of Yucatan. When we have, of course, the Cancun, Riviera Maya tourist development, but also the city of Merida on the inland. Two totally different environments, but we are looking at similar patterns in terms of vulnerability. That societies in those areas and the natural systems are going to face in the very rapid way. So they think, how do you promote a decision-making tool that takes into account those complexities in a way that the vulnerability is not used like something outside that you have to address, something exogenous, but it is part of the socio-political system. So we're creating this platform, these tools, to get this vulnerability as endogenous part. So that's goes with a lot of modeling. And the challenging part is what the new technologies are coming, that are arising, are going to modify all these systems in a very rapid way. For example, the problem is not going to be energy, perhaps, and if you have energy, you have water. If you have water for the population, then you have the opportunity for bringing a lot more people. That changes all of things, but also doing that, it changes the vulnerability patterns. And what is going to happen, that we can foresee that, is that we're going to create inequities, inequalities, injustices in these decision-making systems, because of course it's going to be certain percentage of the population that is not going to provide in the same way. Mm-hmm. So we're in the process of creating these tools so we can provide some data knowledge, so we perhaps can have at the end better policies in order to reduce not vulnerability as an abstract concept, but the very specific problems of the most disenfranchised and poor percentage of the population. Mm-hmm. It's just, so we're trying to address those issues. So I don't know if it's going to happen, but at least what I would like to have a group, a research group, that could address these questions and have a broader impact in this kinds of things.
I see. I saw that like your group, or as you described, you would like to develop like a technical as well as analytical supporting tool, which sounds like it could be in the end take a form like a simulator, mm-hmm. right? So for that analytical tool or that simulator, what are the different components do you see as the building blocks to help you to create results and outcomes, and then you can in turn convey and even visualize, mm-hmm. because as you said, make the invisibles visible.
Yeah.
Right. So what components do you feel that you would like to consider? So basically, I'm now kind of drive a little bit deeper into the technical aspect,
sure.
of your work. And then what component will be the building blocks of your simulator, and then what will be some kind of major outputs do you envision that will be critical to support? with decision makers?
That's very important. I mean, for the kinds of models we have to develop to do that, then there's, of course, we got to create the computational capacities. Mm-hmm. So that's a whole problem by itself. That's not it's not something simple. So we have to train people and have researchers doing this mobilizing the way we're doing these models. And for example, one of the challenges we faced in Mexico and perhaps over here is that trying to find programmers that are research oriented, it's very difficult. That's going to be in high demand for this kind of endeavor. Just computational system professionals that actually do in the scientific computations. That's one thing that's a big barrier. The other barrier is on the way we're communicating the results. That's not a simple way of thinking. It's a key part, and you have to tailor-make the different ways you communicate with different stakeholders. And it is not that simple because you want it to do it in a way that is agnostic. That means the opinion of the technocrat like myself doesn't influence the outcomes of the analysis, and so that you can promote a more democratic way in decision making. But that means that we have to create the capacities in these parts of society, especially in governments, on how you conduct or you accept if they are ready or not of taking this kind of technologies and operate them in a way that is compatible with their recommendations you're doing. So that's another big barrier that it has to be studied very carefully. Mm-hmm. Because otherwise what we're going to have is very big systems that perhaps you can publish a lot of papers with that, and governments that cannot accept those technologies because they're not ready. The problem is that this kind of work with the government side is not a field that is well accepted with academics nowadays. But it's going to be something that we have to resolve, I think, through capacity building programs that work. So I think those two things. I don't see that we have that the problem right now, it's going to evolve in the disciplinary modeling tools that are being developed. Mm-hmm. I think the problem right now is how we integrate the different aspects in a tool that is functional, that actually provides results that are useful. Mm-hmm. I'm not sure we, at least in my part, we have the academic structure to teach this kind of skills that in a systematic way. I mean, in a way that it's actually in a program. Nice. It's like ad hoc. If someone comes with me, I might teach something that and he might learn. It's very medieval. Uh-huh. It's so they learn by doing it. But what we need is to create a program with a lot more people working in these lines. I don't know how to do it.
I don't know either. But I think that's a very good observation. So and I agree with you. It's kind of we do have like models or tools developed by each discipline, like they're developing this disciplinary kind of approach. Of course, I think one of the key contributions that systems engineer is aiming for is to, by integrating all these different tools and knowledge and models together, and we are hoping to capture the emerging behavior, for a complex system, such that, integration revealing emerging behavior and create insights.
Yeah.
Right. So for that, kind of for your work, especially, like, I don't know if you have done any case studies in applying your framework to any specific issues in for example, in Mexico. So for example, from all your research, for example, related to social ecological systems, right? You want to generate insights that will lead to hopefully solutions. So for some, for the relevant complexity or the issues that you have studied, would you share any insights or any kind of solutions you would prescribe to, for example, for a city or for a community in dealing with, for example, or improving vulnerability of a coastal community? So any insights or any solutions that you'd like to share?
I mean, in general, what would that's goes to one important aspect of transdisciplinary research. But that means that I mean, it's a very big word, so you can get into transdisciplinary endeavors from many different perspectives. But there's this normative school of transdisciplinary research that's like a checklist, which I don't like checklists, so I don't like that part. They say, well, did you have a co-design with the stakeholders? Check. Do you have whatever? So if you fulfill this checklist, then that's transdisciplinary. The problem is, if you're talking about complex systems, nobody can define what the problem is.
That's true.
So you don't know who the stakeholders are in very complex systems. I mean, you might have an idea. So in that, at the beginning of this kind of research, on transdisciplinary research, you have to get an agreement of what the context of what you call a problem is going to be about. And there's enough knowledge around to get that to an idea. But that means that it's a process of transformations of knowledge, of translations, communication and mediation of many ways of describing reality in a correct way.
I see.
And then the whole idea in co-design, in co-production of knowledge is that knowledge is intelligible and portable. Well, that's a role for good skills in systems, because you have to be reformal. If my way, the things I have in my brain are going to be transferable, it has to be very strict, very specific, in order to have an accurate communication and a useful communication. So that's a big part of this. How do you start designing this in a way that knowledge is portable? Then you have all these things that you have to assemble together and to integrate. And integration is another important component of this, because so many times you are putting your way of thinking instead of the way of thinking of the stakeholders when you build a model. So that's the part that you have to be very accountable. So the process of doing this has to be very interactive and iterative until you get something that it doesn't represent the knowledge of yourself, that you may not have that intention, but it's only human to do something certain way. That's what I call biases. Instead of reflecting the problems of society. So for me, you need formal techniques. Mathematics are very useful in this way. When you use it in this way, I use mathematics in a way that prevents me to influence the outcome of a model. These are my warnings that I'm doing something that is not correct.
Mm-hmm.
And because the important thing when you formalize in the language of mathematics is that you can be very transparent, specific of the way that you're doing, and you may ask to your counterpart, do you agree with this or not? So that's part of the communication. So instead of thinking of simplistic techniques or simplified versions, what we're talking maybe is perhaps very complex mathematics, that I cannot do it, but are very good mathematicians that can help. But we're talking about responsibility of communicating the essence of we are assembled together through an equation to society, so we can interact. And the power of science about other ways, so that's why we use science in sustainability science. It's not an ideology, it's not something, we're talking about science is that we have explanatory power to others and predictive power. So the stakeholders of society can decide.
That's
not the technocrat.
I really like that, that approach. So it's essentially, yes, so it's kind of technocrat, or scientist,
Mm-hmm.
Sustainable scientist, and we do have a role to play. And I feel our role is really to not only within one discipline but trans-disciplines.
Mm-hmm.
How do we review more fact and more truth and generate more knowledge to empower both the general public as well as the decision makers. So for them
Mm-hmm.
to make decisions based on their choices, I think our role, you can see that our role is not really to make decisions. Our role is really to empower people and inform people
Mm-hmm.
so that they can make decisions. Of course, as about whether the decisions are going to be right or wrong, of
Mm-hmm.
course, the right or wrong are all relative.
Yep.
All right. So, however, at least I think we develop these tools, we develop this equipment, we develop this science, such that they are better informed, they are
Mhm.
better educated,
Yeah.
and they're better equipped to make that
Yeah.
kind of decision. And this is wonderful. I know we are running out of time. I really enjoyed
Well,
our
thank you very
conversation.
much.
Yes.
Yeah.
Thank you very much.
Thank you. Thank you.
Okay, good.